You've done that before. Hopefully you kind of remember that's when you have more than one equation at a time. So you have multiple variables you're solving for. When you are looking for the solution, you're looking for what makes them both true. If you get an answer, so if it can be solved, that's consistent. If it can't be solved, that's inconsistent. You also talked about independent versus dependent. So if you only get one solution, those are independent. More than one solution, those are dependent. So what does it look like in terms of a graph if it's consistent and independent? If we're talking about linear equations. What does it mean? What does consistent mean? Okay, we said a solution makes them both true. So there's a point that makes both equations true. That means they touch each other, right? They hit. Since they're independent, they are two different lines. So this would just be two lines that intersect somewhere. And that point is the solution. It's the point that makes both equations true. If they're dependent, that means you have infinite solutions. So what that means is you have two equations and they are the same line. So you end up with only one line on your graph. Every point on that line is a solution. When would you have no solution? Yeah, two lines that don't intersect, two parallel lines. That's not really parallel. So inconsistent would be two lines that never meet. Pretend those are parallel. I'm not drawing straight lines very well today.
Oh my gosh.
So you've solved these before. You've probably started out solving them by graphing. We are not going to do that method only because it really only is helpful if your answer is a nice, pretty answer and they meet at a point where it's clear to see from the graph. We are going to work on substitution and elimination for solving these. Do those sound somewhat familiar? Yeah. Okay. So we'll start out, first couple examples we will solve with substitution. Let's look at this one. What do I mean when I say substitution? Anybody remember? We substitute. Wow, you guys are on top of it. How do we do that?
You solve one equation for y2 equals something or for x, and then you plug that in for the other one. I remember.
We pick one equation and we solve for one variable. It doesn't matter at all which variable, which equation, whatever is easy. So maybe I want to take the second equation and solve for x. So if you want to get x by itself, you would add over the y. So x is 4 plus y. And then you take that and you're going to substitute it into the first equation. So the first equation was x, but I'm replacing my x with 4 plus y. Plus y equals 8. So we're just taking this x and replacing it with the 4 plus y. So then we add like terms. So we get 4 plus 2y equals 8. Subtract over the 4. Divide by 2, and y is 2. How do I get x?
You plug 2 into y.
Yep. We have an equation right here for x. You could really plug it in anywhere, but this would probably be the easiest place. If I plug my y in there, x is 4 plus y, and if y is 2, x would be 6. I would like for you to write these as an ordered pair. So 6, 2. The variables don't have to be x and y. We're used to that. They could be anything. Just put them in alphabetical order. So if my variables were a and b, you do a comma b. If I had x, y, z, just put them in that order, alphabetical order. So is this consistent or inconsistent?
Consistent.
Consistent, we got an answer. Are they independent or dependent? Independent, because we got one answer. Okay, and we'll look at cases where that's not true. Why don't you guys try this? So here's yours. You can solve either equation for either variable. Is there an easiest path? Yeah, I would probably take the first equation and solve for y. That might be the easiest option.
Get someone
Oh, I don't get it.
The video.
The one of her pushing?
No, he came
No,
up
he
behind
came,
her
yeah.
and like.
In the video.
She jumped.
All I saw was a
Alright, so did you guys start off subtracting over the 2x?
Yes.
And then we have to plug that into the second equation because we haven't used it yet. So we have negative 4x plus 30 minus 12x equals negative 2. So that gives us a negative 16x. If I subtract over my 30 equals negative 32, divide, and x is 2. So if you plug that in, y is 5 minus 2 times 2, which is 1. So my answer is 2, 1. How could you check this? Plug it in. You need to check both. 2 times 2 is 4, plus 1 is 5, negative 8, plus 6 is negative 2. Don't fall into the trap of thinking it has to be nice, pretty answers every time. You might have some fractions or decimals. That's okay. Are we good with substitution?
Yep.
All right. Let's talk about elimination. Let's not do it. Yeah, let's go ahead and do this one.
Elimination.
Sit in for a second.
I was sleeping.
So the goal with elimination is to be able to add these equations together and eliminate one of our variables. That happens when you add together opposites. So like 3 plus negative 3, 5 plus negative 5. So what we have to do before I add these is we have to multiply by something so that one variable will cancel out. So you pick your variable. If I wanted x to cancel out, what would I have to do? I think if we just did positive 2, then it would be a 4x and a negative 4x, and they would cancel. If I wanted my y's to cancel, what would I have to do? Multiply the top by negative 6. So it doesn't matter which one. Let's cancel x. So we're going to take top times 2. And you have to distribute that 2 to everything. I did not change my second equation. And when I add these, 4x plus negative 4x cancels. 2y plus 6y is 8y equals 22. Divide by 8, so 22 over 8 would reduce to 11 over 4. Then how do we get x? Plug it in. Either equation, I'll just go with the first one. So 2x plus y, which is 11/4, equals 5. Subtract over the 11/4 and divide by 2, and you get 9/8 for your x. So the answer is positive 9/8, positive 11/4. Questions on that one? And we know we can check them just by going back to the originals. Let's do another elimination problem. So pick your variable. What do you want to eliminate? Y. Okay, if I want to eliminate my y, what am I going to multiply by? Negative 2. So, that gives me a negative 4x minus 2y equals negative 10. And 4x plus 2y equals 8. When I add these, my x's drop and my y's drop. So I have 0 equals negative 2. 0 cannot equal negative 2. So that is a no solution. Also, what did we call it when there was no solution on these? Inconsistent. On any assignment with these, I would say identify any inconsistent systems. So I would like for you to go ahead and write that if they are inconsistent. Let's do this one. What do you want to cancel out? X. So what do we multiply by? So if we do that, we get negative 2x minus 4y equals negative 8. And positive 2x plus 4y equals positive 8. When we add those together, we get 0 equals 0. That is true. So it is infinite solutions. We are going to write that a little bit differently than you probably have in the past. So it's infinite solutions, but does any ordered pair I pick work? No, it has to fall on the line to begin with. So in these scenarios, I will tell you, like in the directions, it will say something like, if there are infinite solutions, write the answer with, and I'll pick a variable, maybe y, arbitrary. Here's what that means. If I keep y arbitrary, I want to write what my ordered pairs will look like. But this is saying if we keep it in terms of y, y is the variable. Okay, so y is just itself. I have to figure out what I would use for my x. So just take one of your equations. If I took the first one, can you solve that for x? Can you get x by itself? Yeah, you just subtract over, so x is 4 minus 2y. So my solution would be every ordered pair where the x value is 4 minus 2y and the y value is y. Okay, and we'll write it like that, a formula for what our ordered pairs would look like. If I had said to write it with x arbitrary, that means in the ordered pair you keep x and you have to solve for y. So if I took this equation and solved for y, you would subtract your x, divide by 2, so you get 4 minus x over 2. So I could ask for either variable. Does that make sense? It's just a way of describing which points fall on that line. These all okay so far? So this is the section 5.1. I'm going to cover 5.5 now, which is the same thing, but with non-linear systems. So that means the graphs aren't just lines. You know, I might give you a line and a parabola, or two parabolas, or a circle and a line, and ask where they meet. The difference is we might get more than one answer. We don't necessarily know. So let's take a look at this one. Do you guys know what the first equation is? What its graph would look like? You have an x squared. Yeah, that's a quadratic. That's a parabola. And the other one is a line. Okay, if I want to solve it, we use the same strategy, substitution and elimination. Essentially here, we kind of have like three variables. I have an x, a y, and an x squared. I want to get rid of my y's because x squared and x, we can work with those. How could I eliminate my y here? Yeah, these are already opposite coefficients. If we just add these together, x squared and x are not like terms, so that's just x squared plus x. The y's cancel. 4 plus negative 2 is 2. How do you solve a quadratic? Set it equal to 0. Right, and then we can do the shortcut method here. So multiply to negative 2 and add to positive 1. Positive 2 and negative 1. If we set those equal to 0, we get x to be a negative 2 and a 1. Is that okay? Now, I need to get y for each of these. Okay, I know I have one ordered pair where x is negative 2 and one ordered pair where x is 1. So we just have to plug them in either equation. So let's just say I went with the second one. So that means negative 2 plus y equals negative 2. If I add that negative 2 over, we get y equals 0. So when x is negative 2, y is 0. If I put in a 1, then 1 plus y equals negative 2. So y is negative 3. So 1, negative 3. And we got 2 points on that line, which would be reasonable. I mean, if you think about a parabola and a line, they could certainly meet twice. If you weren't sure, you can check them. Plug both points into both equations, and it should work out. Is that one okay? I'm going to do one or maybe two more, and then I'm done. What would you do? Yeah, you just add these. 1x squared plus 2x squared is 3x squared. Positive y squared and negative y squared cancel. 4 plus 8 is 12. 5 by 3, so x squared equals 4. To get rid of a square, we need, and when you do square root, you have to do, so x could be positive or negative 2. All right, plug those in and find your y. So if we put in a 2, we get y squared equals 0. So y is 0. What's going to happen when you do negative 2? You get the same thing, because negative 2 squared is also 4. So we had 2, 0, and negative 2, 0. One last problem. Okay. Let's say I want to eliminate x squared, what would you do? Negative. Positive 4x squared and negative 4x squared cancel. Negative y squared equals negative 9. Okay, and then what? And then to get rid of a square, you square root, and with that you have to do plus and minus. So y is positive or negative. So if I plug that in, so in the first one, we get x squared plus 3 squared equals 5. If I subtract my 9, I get negative 4. Square root plus and minus, what's the square root of negative 4? 2i. You notice I put in one y and I got out 2 different x's. This is 2 different ordered pairs. That means you could have positive 2i and y is positive 3, or x could be negative 2i and y could be positive 3. Am I done? No, I haven't put in my negative 3 yet. And negative 3 squared is also 9. So we get the same thing. So this one had a total of 4 solutions. We also have 2i negative 3 and negative 2i negative 3. Alright, so really the only difference with the nonlinear, you get multiple answers sometimes. Not a guaranteed, but we could have anywhere from 1 to 4 answers. Any issues with this? There's a handout posted on Classroom. I think it's 8 questions. Make sure you read your directions. I did ask for you to do the first couple by substitution, just so you are using that, and then